Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, salam, nama budaya, dan salam sejahtera untuk kita semua. Today, I will present on the topic of LKM-4 biochemistry, cell bioenergetic, the citric acid cycle, and oxidative phosphorylation. Before we begin, let me introduce myself. My name is Salsa Vidoe LKM-4. You can call me Salsa. With lesson is 01. The case study is a patient presented with muscle weakness, fatigability, and intolerance to physical activity. Laboratory tests revealed low ATP produce, high NADH accumulation, mitochondria dysfunction, decreased activity of the electron transport chain complex. The physician suspected a disorder of the citric acid cycle and oxidative phosphorylation, leading to suboptimal energy production. Explain the primary function of the citric acid Krebs cycle in energy metabolisms and its relationship to acetyl coenzyme A. The Krebs cycle generates NADH-FADH2 and ATP or GTP from acetyl coenzyme A for cellular energy production. Describe the main produce of one cycle of the Krebs cycle ATP or GTP and NADH-FADH2 and explain their roles in cellular energy production. One strand of the Krebs cycle produces 3 NADH, 1 FADH2, and 1 GTP or ATP, which contribute to ATP synthesis. Third, based on the case study, how can a disruption in the Krebs cycle lead to a decrease in energy production (ATP)? Impairments of the Krebs cycle decrease NADH and FADH2 production, resulting in reduced ATP synthesis. Right. 4. Explain the mechanisms of the electron transport chains in the inner mitochondrial membrane. Electrons from NADH and FADH2 are transferred through protein complex in the inner mitochondria membrane to generate a proton gradient. 5. Analyze the roles of NADH and FADH2 in the electron transport chain and how they contribute to ATP formation. NADH and FADH donate electron to the electron transport chain to support ATP production. 6. Explain the concept of oxidative phosphorylation and how the proton gradient is used to produce ATP. Oxidative phosphorylation uses the energy of the proton gradient to produce ATP via ATP synthesis. Conceptually calculate the amount of ATP produced from 1 NADH, 1 FADH2 and explain the difference in energy yield. 1 NADH produces approximately 2,5 ATP, whereas 1 FADH2 produces about 1,5 ATP because they enter the electron transport chain at different complex. Why can mitochondria dysfunction cause fatigue and nucleus weakness? Explain biochemical. Mitochondria dysfunction reduces ATP production, leading to fatigue and nucleus weakness. 9. Explain the factor that regulate the batch rates of the Krebs cycle and the electron transport chains. ATP or ADP ratio, NADH and NADH positive ratio. The Krebs cycle and electron transport chain are regulated by the ATP or ADP and NADH or NADH positive ratio within the cell. 10. Explain the relationship between glycolysis, the Krebs cycle, the electron transport chain, in the overall production of energy within the cell. Glycolysis produces pyruvate, the Krebs cycle generates electron carriers, and the electron transport chain produce most of the cell ATP. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.